What's going on, everyone? My name is Kodamore and welcome back to Electronics episode 7. In this episode we are going to learn how to choose the proper value of resistor to put into a circuit. Now in our case we just learned about LEDs, so we need to know what resistor value, how much resistance we need to put into a circuit so that our LED will work and not burn out. Now there's a really cool equation for doing this for any electronic component that you need to figure out if you need a resistor for. But you need to know some information first. First, you need to know what component are you trying to get the resistance value for, and I'll explain all this in a little bit, don't worry. Then, you need to know the voltage, I'm just going to put V, you need to know the voltage of your power source. I'll just abbreviate it like that. Then, you must know the forward voltage of whatever component you have. And then you must also find out how many amps your component uses as well. Now this all looks crazy, but don't worry, we know all of this. First of all, what is our component? Well, in our case, we want to figure out how much resistance value we need for an LED. The LED is our electronic component. Like I said, this equation will work for any electronic component that you need to figure out if you need resistor for. Okay, so an LED is our component. Next, we need the voltage of our power source. In my case, I am going to be using a 9-volt battery. If you have a battery holder for, say, 2 AA batteries, that's going to be, I believe, 3 volts. You just add up the voltages on the battery. But I'm just going to be using a 9-volt battery. Alright, now what in the world is forward voltage of our component? Well, in order to figure this out, you need to know the manufacturer of the component that you have. So who created your component? If you know that, you can go online, look up the manufacturer of your LED or of your electronic component, and they should have a data sheet online that shows you what the forward voltage would be. In my case, when I ordered my LEDs, it came with a little note card that told me the forward voltages of every single LED that I ordered. So for my LEDs, the forward voltage for almost all of them is 3.2 volts. That's basically how many volts the LED will use up. If you don't know this, that's fine. Just start off by using a 1.5 kilo ohm resistor, and that should be plenty to not burn out your LED. But it is important that when you order electronics components, know who created them so you can look it up online, or save any of the cards that they send you that gives you information about the product. So the forward voltage you can really get by just looking up who created your LED or your component. And next we also have to have the amps that our component uses up. This is also found in the same way by looking up the manufacturer and the data sheet of your component. In my case, the LEDs that I have take up 24 milliamps. I'm just going to put MA. Now because this equation only works with amps, we have to convert milliamps to amps. 24 milliamps is basically 0.024 amps. And I'm assuming that you can figure that out. I just took my 24 milliamps and multiplied it by 0.001, and that'll get you amps. Now we have all of the information we need for this equation to tell us how much resistance we need. Basically, what we are going to do is we are going to say the amount of resistance we need in this circuit is going to be equivalent to, and I'll write it out first, we have our power source voltage minus the forward voltage of our component, all divided by the amount of amps we have. So if we actually plug in numbers for this, we're going to say resistance is equivalent to, if we look at our power source voltage, I'm going to be using a 9-volt battery, so it's going to be 9 volts, so 9 minus the forward voltage of our component, which my LEDs take up 3.2 volts, so 3.2, divided by the amount of amps our component takes. In our case, 0.024 amps. So I'm just going to write 0.024. So if we simplify this, R equals 9 minus 3.2 is, I believe, 5.8. So we have to do 5.8 divided by 0.024. And if we whip out a calculator, this is equivalent to approximately, rounding all the decimal points, 240 ohms. There we go. We know if we want to use my specific LED in a circuit where the power source or the battery is a 9-volt battery, we must have a 240 ohm resistor in the circuit, or somewhere around there. It doesn't have to be exact. to operate my LED at its maximum potential according to the manufacturer. So it seemed like quite a bit of work, but eventually you'll begin to memorize this equation. Just write it down somewhere. You are going to be using it a fair amount. If you ever question how much resistance you need for a circuit, you look up all this information, plug it into the equation, and you'll get the approximate resistor value. Now, resistors don't come in every single value, so you are going to have to approximate. Say I don't have a 240 ohm resistor. Say I have only, I don't know, a 280 ohm resistor. That'll be plenty. I mean, it's even more than the recommended resistance value. Even if I have to go a bit less than 240, that's completely fine. My LED will still work and probably not burn out if I don't go too far under. Now, if I only have a 100 ohm resistor, that might be a problem. But I hope that all made sense. As long as you know what component you are trying to get the resistor value for, in our case an LED, you can look up all the other information online, your forward voltage and your amps, and obviously you know the power source because you're the one providing it, the battery, and then you can use this equation. I hope this all made sense, everyone. If you have any questions whatsoever, let me know down below in the comments. And either I or someone else will hopefully answer your question or help out with any of your problems. Again, thanks for watching, everyone, and I'll see you guys in the next video.